What's up everybody, welcome back to the channel. Today we're going to be going over a tutorial on how we can calculate progressive passes. So if you're wondering what is a progressive pass is a pass that is progressive. That was dumb. In its truth, it is a pass that is progressive. It's a pass that's getting you closer to the goal, and there's a couple of parameters and there's a lot of different definitions as well on what a progressive pass is. So what I'm going to be showing you is how you can calculate a very simplistic form of a progressive pass. So the way that we're going to be doing it is by using a very common way to do that, which is just taking all the open play passes that are in the attacking 60% of the field that move you 25% closer to the goal. This is described really well in this article right here by American Soccer Analysis, one of the better analysis and analytical websites and as well accounts. There's a lot of people on Twitter that contribute to this as well, and he goes over progressive passes, and this is probably something that if you're wanting to learn more about progressive passes, and you can learn a lot from this article. I've read through it, it's fantastic. So how we're going to be doing this is we are going to take this definition that I've created that say open play passes that move the ball 25%, more than 25% closer to the goal. So these are called progressive passes. As you can see, he has different pass categories. So these can be through balls, cutbacks, crosses, progressive passes, and long balls as well. So these are just a couple of examples that kind of show it. So I would recommend that you definitely check out this article. I'll leave a link to it in the description and you can go check that out. So to calculate if it's actually 25% closer to the goal, we're going to end up going back to our algebra. I don't know if he uses this in calculus, but I sucked at calculus. But what we're going to be using is just the distance formula. So we're going to measure the distance between the two points, and we're going to use that to measure to see if the end location of the pass is 25% closer to the goal than where the starting point was. So we're going to jump into a Jupyter Notebook, and we're going to be using some data that we used in a video before to create dashboards, and that is from the Europa League final. That's just kind of some data that I have, so we'll jump into using that. So just make sure that you create a new Python file, and we're just going to jump into it. So the first thing that we're going to need is we're going to need to use pandas. So we'll say import pandas as PD, and then as well we're going to end up using NumPy. We'll say import NumPy as NP. And then as well, we're gonna use, I'll show you how you can plot it at the end. So we're gonna say import matplotlib.pyplot as PLT, and then we'll use MPL Soccer to go ahead and create the pitch that we're gonna be plotting on. So we'll say we'll say from MPL Soccer import pitch. So run those, just make sure that it runs properly. And then the next thing that we're gonna do is we're just gonna read in our CSV that has all of our data. So we'll say df equals pd.read_CSV. And then the name of this file, so you need to pass in the file path. Since this file and my CSV are both located on my desktop, we're just gonna pass in the name of the file. It's called europafinal.csv. So you run that, and we can just check this out real quick. We can say df.head. We can kind of see what this is. So looking at this data frame, looking at this file, we have the minute, the second, the team ID, the X and the Y, the period that it happened, the type, the outcome, player ID. So player ID is the number of the player. And then we have the end X and the end Y. So where the pass ended up, or wherever the end location was of that certain action. So as you can see, what we need to do first is we need to filter this data frame so that it has the data that we want, not all of the data. So the player that we're going to be looking at is we're going to be looking at all of Danny Parejo's passes for Villarreal. All of his progressive passes is what we want to be able to find out. So we are going to start with that question and then go about solving that. So the first thing that we're going to need to do is we are going to need to filter for team ID. So the best way to do this is if we just say df equals df.loc And then we'll pass in again df, so for our data frame, and then these brackets again. And then on the inside, we want to put our column. So we'll say team ID. And then we have to do the double equal sign. So that means is equal to. So that's the way that we check it is equal to something rather than setting it equal to something. And then we need to just pass in a string of via real. Did I spell that right? Should have. Okay, so now we have our data frame is equal to only via real. We can run this head again, and as we can see, our team ID is just via real. So then we're gonna do the same thing, but we're gonna filter the type to only be passes. So we'll say df equals df.loc, just same thing again, df type is equal to pass. And then after we do that, we want to filter for just Danny Parejo. So let's go ahead. I forgot his number. Danny Parejo number. So he is number 5. So what we're gonna do is we're gonna do the same thing. We're just say df equals df.loc, df with the brackets, then a string player ID is equal to 5.0 because these are in floats and not just single numbers. So we'll run df head just to make sure we're on the right page. And as you can see, these are all of Danny Parejo's attempted passes. So if you wanted to, you could filter it for just successful passes. You could filter it for all the only open play passes as well if you had that kind of data. I think StatsBomb has that kind of data and stuff, so you'll be able to filter for that. Yscout as well has that kind of information. So what you're wanting to do is now we need to start calculating the distance between the points. So first things first, what we're going to do is we're going to actually create our pitch just so we can get a visualization of what we're doing. So if we say pitch equals pitch like this, and then we can say fig comma axis ax equals pitch dot draw, and then it will plot the MPL soccer pitch. And we're actually going to use the StatsBomb version, so we'll say pitch underscore type equals StatsBomb. Oh, it actually needs to go in this right here, not in the pitch.draw. So pitch underscore type equals StatsBomb, just like that. And there we go. So now we have a pitch. And this pitch is, the x-axis is 120 by 80. So our data actually is 100 by 100. So we need to make a couple of adjustments there. So we'll say df.x equals df.x times 1.2. So what this is doing is it's multiplying our x values by 1.2 so they're scaled correctly. And then we're just going to do this for our other location columns as well. So if we say df.y equals df.y times, and then to get the correct scale, we need to times it by 0.8. And then we'll say df.endx equals df.endx times 1.2. And then df.endy equals df.endy times 1.2. So we'll run those, and if you look at the x and the y, the x is going to be a little bit bigger and the y will be a little bit smaller. So our x went from like 34 to 40, our y went from 14 to 11. So we know that we're scaling it correctly. And so now that we know that, what we need to do is we actually need to know, we have to make sure that we're using the distance formula to calculate the distance, between the goal and the pass. So we're just going to use actually the center of the goal as our distance that we're going to be using. So our location for midfield is 60, 40. So 60 on the x-axis, 40 on here, since half of 120 is 60, half of 40 is, or half of 80 is 40. And if we come all the way over, so this point, the center of the goal is going to be 120 on the x, and 40 on the y. So we'll use that to calculate the distance of our beginning location and our end location as well. So this is where the actual distance formula is going to come in. And to do this, we're going to create eventually we're going to create 3 columns. And the first one is going to be for all the beginning locations. The second one is going to be for all the ending locations. And then the third one is where we're going to say if it was a progressive or not. So let's start with the beginning. So to create a new column, we just say df and then brackets and say beginning. And then we're going to use the distance formula here. So if you remember the distance formula is right here where it says it is the square root of x2 minus x1 squared plus y2 minus y1 squared. So if you don't remember that, go ahead and Google it and learn a little bit about it. This is essentially for calculating the distance between 2 points on a 2D axis. So that's essentially all we're going to be doing. So what we're going to do is we are going to take the square root. So we do this by saying np.sqrt, so square root. Then in parentheses, we need to pass in np.square. And then we need to do 120 minus df brackets x. So we're taking the squared of 120, so x2 minus x1, which is our starting location. And then on the outside of that, we need to do plus np.square, and the same thing but for the y's. So we're going to do 40 minus df y. So that's our beginning values, and that's how we're calculating the distance between our beginning location and the goal. So if we run that, we can actually check out what it looks like right here. So this is the distance between the opposition goal and where the pass started. So now we want to calculate where it ended and the distance between that location and the goal. So there, we'll come back down to the same cell and we will say, sorry, having a hard time typing. We'll say df end equals, and then we're just literally doing the same thing, but we're going to be using our end x and our end y. So we'll say np.sqrt and then np.square 120 minus df brackets and then end x. And then on the outside of that, we'll do plus np.square and then 40 minus df and then end y. So that's calculating our end values. So the distance between our end location and the goal, the center of the goal essentially. So if we run that, we now see that we have the end. So the beginning location was 84 and 82. So it was a little bit closer. This one actually looks like it got further away. This one got closer, further away, etc. So now what we're going to do is we're actually going to create another column, which we're going to see if the difference between these two is 25% greater or closer to the goal. So to do this, what we're going to do is we're going to say df progressive. So we're creating another column equals, and then if we do a list, we're going to do something called list comprehension, which is where we can basically create a column with a list where it's kind of doing like a for loop. It's kind of an advanced topic, but I'll show you a little sneak peek, I guess, of how you can do it. But to do this, we just say df, and then in here we call the column and we say end, and then outside of here another pair of brackets with x, and then we'll go out here and we'll say the slash, so the forward slash for the divide symbol. And then we'll do the same thing for df. Sorry, this needs to be end x, not end. Oh no, sorry. It does need to be end because we're calculating this one, not end x. So then we're going to do another pair of parentheses, and we will say df with our beginning. And then outside of here, do x. And then outside of the parentheses, we do less than 0.75. So this makes sure that our pass is at least 25% closer to the goal. And then we will say for x in range length, so len, and then df dot beginning. So just a quick little overview of what this is doing, this list comprehension. So we're creating a new column called called progressive, and it's going down each row. So this is what the for loop's doing in here. So it's going to go down each row of beginning, and it's going to say, okay, for each row in beginning, we are going to divide the the end value of that row by the beginning value. And if it is less than 75, if it's less than 0.75, then it's going to be true. Otherwise, it is going to be false. And then one thing that you need to make sure that you do as well is that you actually reset your index. So as you can see, we have 9, 22, 31, 105, 136. We actually need that to be 0, 1, 2, 3, 4. So what we're going to do is we're just going to come up to one of these places where we filtered our data frame, and we'll just say .reset _ index. You should probably be doing this earlier than I'm doing it right now, but just make sure that you do that. So now if we type in df.head again, you can see that it's 0, 1, 2, 3, 4. You can just ignore this column right here. It's not gonna affect anything. So then we'll just make sure that we run this real quick, and we can go back to our data frame. And as we can see, we now have our progressive column. So let's check and see if we have any trues. So we'll filter it one more time. We'll create another cell, and we'll just say df equals df.loc. df progressive is equal to true. And then we'll do .reset _ index so that we can reset our index again. And let's check it out. So these are all of his progressive passes. So as you can see, the distance is drastically changing on these, so it's getting closer to goal. So in the beginning it was 37, then it became 7, and you can just kind of go down and check all those out if you wanted to. I'm using head. So if I put in 10 here, we get the top 10 of them. So that's that's Danny Parejo's, it looks like, for the first little bit. I don't know how many there are. Let's say if we do 20. So he has 11 progressive passes that he completed in this game. So pretty cool that we can now calculate that. So what we're gonna do is I'll just show you how you can plot that. And what a lot of people do as well, and something that I do, is I only use the attacking 60% of the field. If you're looking at defenders though, you might wanna use the whole field. If you're looking at, it depends on who you're looking at. A midfielder probably just gonna end up using the whole field as well. It doesn't really matter how you do it, I guess, because this is just a really simple way. But with other definitions and the way other people define it, you may have to eliminate a lot of these so that you're looking at different things, and you're looking at where the pass started. If it's in this specific zone, then it has to do this for it to be considered a completed pass. Like we look at Y-Scout, for example. They say a pass is considered progressive if the distance between the starting point and the next touch is at least 30 meters closer to the opponent's goal if the starting and finishing points are within a team's own half. So they're using meters here, and they have like different locations depending on where the initial ball was played from. But we're just using the simple one. So we're just using all progressive passes. As you can see, actually, he had a lot of unsuccessful progressive passes. So if that's something that is part of your analysis, something you can look into. So to actually draw these, we can use our nifty tool from MPL Soccer, and we can just say, and we'll just say pitch.lines. So we're using MPL Soccer, and then we need to pass in our X, our Y, our end X, and our end Y for all of these passes. We'll say df.x, df.y, and then we can do df.endx, and then we'll do df.endy. And then as well, I like to put a comment is what it is in Matplot or in MPL Soccer, and then just say comment equals true. And then as well with NPL soccer, I always forget this. You need to say AX equals the axis you're working on. Since we only have one, AX equals AX. And there we go. We have all of his progressive passes. So as you can see, some of these are coming from corners, from dead balls. So if you have that data, you might want to be eliminating some of that. And as well, some of these, maybe like this one right here, you might want to eliminate as a progressive pass because it is going backwards. It doesn't really look like it's progressive, but by the standard of a progressive pass, it is closer. The distance is closer. So there's a lot of things that you're probably gonna have to do your own analysis for, but this is just showing you basically how you can calculate this in a very simplistic way. And then, you go out and you do your own analysis, because that's the way that you're actually going to be able to understand and better yourself in sports analytics. And it's really important to kind of understand that for yourself. So I'd recommend reading this article, this American Soccer Analysis article. It's written by fantastic people, so I definitely recommend you go check it out. And as well, if you do have any questions, be sure to hit me up on Twitter, or you can join the Discord, which is the Football Analytics Discord. Link is in the description below. You can come check that out. So that's it for this video. Thanks so much for watching, and I will be sure to catch you in the next tutorial. Peace.